Okay, so this is a short video on how to accomplish this life cycle of the stars using the star in a box. So the star in a box, what it basically is, it's a version of the HR diagram in the reference tables, but it's interactive. A few things you can do on this, you can change the mass of the star. So our sun is one sun, so the mass of our sun is one. So this would be the path of this would be the path through the HR diagram for our sun. If you notice, the main sequence is all yellow. It's this yellow trail here. Our sun starts off about here, and it goes to a red giant, which is shown up here. And as it becomes a red giant, it's actually going to engulf the Earth, and then eventually it's going to end its life as a white dwarf. So on here, describe how the sun changes over time. Use that, figure it out. At which stage does the sun spend its longest time? Again, look at the simulation. Okay, so now what we're going to do is we're going to be adjusting the mass of the star. So when we do that, what we're going to use is this. So we're going to be using 0.2, 1, 6, 20, and 40 for the go formative. If you want to see what the final stages are, so for example, let's say you want to see what the final stage of a star that has a mass of 10 times the size of our sun. I'm going to change this to very fast so it does a simulation quickly. So it starts off as a main sequence, and then it goes to a red giant, and it winds up as a neutron star. So that would be the correct answer if you guys had mass of 10. Then the next ones, so follow the evolution of 5 stars with the corresponding time on the main sequence. So for that part, what you're going to be using is the data table. So it gives you duration in millions of years, and it gives you main sequence. So for example, if you were asked for a star that has a mass of 10 times the size of the sun, the correct answer would be 24.46. However, that's not one of your ones you're going to be asked. So I'll just do one with you quickly. So 20 times the mass of the sun is one of the ones you're going to be using. So if you wanted to know how long that was going to last on the main sequence, 8.82. So if you look on here, there it is. So 20 goes with 8.82. Okay, the next one is match the different with the corresponding final state. So again, you're going to be going through each one, simulating it, and seeing what it winds up as. For this part here, the total lifespan of the star, you simply go here and you add these two up. So for 20, for a star that has a mass of 20 times the size of the sun, it's going to be around 10 million years. So if you look in the go formative, look for the one that's the closest to 10 for that particular one and match it up. Okay, the maximum radius. Okay, so for that one, again, it gives you the radius compared to the sun. So for the one that has a 20 times the mass of the sun, the largest radius is going to be 1,500. So you go here, there it is right there. So 20 goes at 1,500. For luminosity, this is where it gets a little tricky. So for luminosity, you're not going to use a data table. What you're going to be doing is looking at the actual X and Y axis. So luminosity is brightness. So what you're going to do is you're going to take this red line and bring it up to the highest point in the line. For example, for 20, the highest number is 222,818. So you go back to here and see which one is the closest to that number. Again, these are very, very sensitive. So the numbers are going to change quickly. So it's around 200,000 is the luminosity or brightness. So you're looking for the one that's close to that number. The next thing is asking for temperature. So that one you're going to be using the x-axis. So again, we're going to do 20 together. So if you look at 20, mass of 20, this one you're going to be looking on the x-axis. And the crazy thing about this diagram is that the closer you get to the origin, the higher the temperatures get. So the highest temperature for this star is going to be right around here. It's going to be around 34,000. So you're going to go here, look for the one that's close to 34,000, and that's going to be your correct answer. For the rest of these are just questions based on the diagram. After you've done all of this stuff on star in a box, you should have a pretty good handle on how to answer these questions. There's a few things on here that you can play around with. You can check out the temperature as it goes through its life cycle, see how the temperature goes up and down. You can also check out the luminosity, how long it takes at a particular time, and the mass of it as well. So the mass will change because the star gives mass off as it's radiating. It ejects stuff into space. So the star's mass is going to decrease over time. And that is about it. So good luck on this assignment.